Hello everyone. Today I am going to explain about BFS and DFS. The word BFS means breadth first search and DFS means depth first search. These are graph traversal algorithms used in artificial intelligence and data structures. Let us see what is meant by BFS and DFS. First, BFS. BFS is a graph traversal algorithm. Graph means a collection of nodes and connections. Traversal means visiting all nodes one by one. Algorithm means a step-by-step procedure to solve a problem. So breadth first search is a method used to visit all nodes in a graph. The word breadth means width. That means BFS visits nodes level by level. It does not go deep first. It covers one full level, then moves to the next level. The working procedure of the BFS would be like queue. First in, first out means for it will be first inserted and deleted first. First element added will be removed first. Let's see the rules for BFS. There are 6 rules in BFS. Starting from the root node, which means root node means the starting node. Next, visit the starting node first, and it add its neighbor node to the queue in the method of first in first out. The first step would be take the first node from the queue and visit it. The fifth step would be again add its neighbor to the queue. The sixth step would be repeat until all nodes are visited level by level. Let's see an example for BFS. This is an example for BFS. If we start from node A, first level would be A, the second level would be B and C, the third level would be D, E, F and G. These are represented in this diagram. Let's see the output would be A, B, C, D, E, F and G in the format of queue. This is level by level traversal. Now let us move to the program. This is an example program for BFS. First, we import DQ from collections to make a fast queue. Then, we create a graph using an adjacency list. Each node stores its neighbor. For example, A connects to B and C, B connects to D and E, and C connects to F and G. Next, we define a BFS function that takes a graph and a starting node. Inside, we make a visitor list to remember visitor nodes and a queue. With the starting node, we run a loop while the queue is not empty. In each step, we take the first node from the queue, check if it is visited, print it to add it to visited, and add its neighbor to the queue. Finally, we call BFS graph A, and the output of the program would be A, B, C, D, E, and F and G as the same before of the example graph. Okay, now let's move to the DFS, depth first search. Okay, now let us start with the depth first search. It is also a graph traversal algorithm, but it works differently from BFS. The word depth means going deep. DFS goes deep into one branch before coming back. It explores one complete path first. How does DFS work? DFS uses a stack, last in first out method. The last element added, it will be removed first. Okay, let us move to the rules of DFS. The rules of DFS are, it is starting from the root node, visiting the starting node, go to one neighbor, continue going deeper. If no unvisited neighbor is available, go back. This is called backtracking. The word backtracking means returning to the previous node. Continue until all nodes are visited. As BFS, DFS is also visiting all the nodes. This is the common difference between BFS and DFS. Okay, let us move to the example. Let me explain DFS by an example. Okay, let's start at A. As a step 1, we start at node A and visit it first. Then we look at A's neighbor. There are two neighbors, B and C. DFS always goes deep. So we move to the first neighbor B. As a step 2, from B, we visited it and check its neighbor. It has D and E. DFS goes to the first neighbor D. And next, we visit D. D has no neighbors, so we backtrack to B. Back to B, we visit its next neighbor E. E has no neighbors, so we backtrack to A. In step 5, back to A. We now move to the next neighbor C. We visit C and check its neighbor F and G. DFS goes to F first because it's its first node. In step 6, we goes to F. F has no neighbors, so we backtrack to C. In step 7, back to C, move to G. Here we visit the next neighbor G. G has no neighbors. Now all nodes are visited and DFS traversal is complete. This is an it's an exact example for DFS. Now let's move to the program. First, as BFS, we create a graph using an adjacency list where each node stores its neighbor. Next, DFS explores nodes by going as deep as possible along one branch before backtracking. Here, we define a function DFS with a graph current node and visiting list as input. Next, inside the function, we initialize the visitor list if it's empty. Then we visit the current node, mark it as visited and print it for each neighbor. If its neighbor is not visited, we call DFS recursively to go deeper. Finally, we call DFS on the starting node to traverse the entire graph, and that's how DFS works. Now, the concept of BFS and DFS is explained clearly in this PPT. That's it. You learned DFS in Python and BFS in Python. Keep exploring, keep coding, and have fun with graphs. Thank you.